In this lesson, we're going to talk about solving linear equations. First, let's go over some more vocabulary. So first, an equation is just a mathematical sentence saying that two expressions are equivalent. So we talked about expressions last time. So when we did evaluating expressions, we were given an input. And so we're doing the same thing now, but we're seeing what input is going to make the two equivalent. Now that word equivalent just means that there are two or more things that are exactly the same. And so that's a very important word because we want everything to match up exactly. So let's work an example. And while we work this out, we're going to write the steps out to the left. Our first step is we want to make sure that both sides of the equal side, both expressions, are as simplified as they possibly can be. So let's do that. On the left, I have these parentheses, and I have this -1 outside the parentheses. So I'm going to distribute that in to say 10 minus -1 times 8x would give me -8x. Then -1 times 3 would get me -3. And now I can combine these like terms, the 10 and the -3, to get 7. So that's my simplified expression on the left. Let's do it on the right now. I've got 9 times 2x minus 5. So 9 times 2x would get me 18x. And then 9 times -5 would get me -45. And that's as simplified as it can get. There's no like terms for us to combine. So I'll rewrite that down here. And now for step 2, we want to get all of our variables on one side and all of our regular numbers on the other side. Now when we do that, when we're moving something over the equal sign, we need to make sure that we change its sign because we're moving it across. So let's do that here. It doesn't matter if you move your 18x or your 8x. It doesn't matter which one we do. Typically, I like to move whichever one is smaller though. So I'm going to move this -8x to the other side. And that means on the right-hand side, I need to move my constant, which is just my normal number, um, to the other side. So on the right, I have 7, and then I'm moving this -45, but when I move it over that equal sign, it needs to change its sign. So the negative is going to become +45. That's going to be equal to my 18x. And then when I move the -8x over, it needs to become +8x. And now I can simplify these like terms. I have 7 plus 45, which will get me 52. And then on the right, 18x plus 8x would get me 26x. Now for step 3, I need to multiply or divide the x term. So what we're hoping to do here is we're trying to get the x by itself. So if I have 26 x's right now, I can divide by 26 just to get that 1x because 26 divided by 26 is going to cancel out. That's just equal to 1. And so now we can do 52 divided by 26, and that's going to get us 2. So x is equal to 2 here. And so now my fourth step is we want to check this in Desmos. And I'm going to show you how to do that now. So just like in our last lesson, what we want to do is we want to plug in a variable input. So the two expressions that I had were 10 minus 8x plus 3. And my second expression that I had was 9 times in parentheses 2x minus 5. And so now what I want to do is remember that x and y are graphing letters. So I'm actually going to change both of these x's to a's. And then I can add in a at the bottom. And we found that x was equal to 2. So I'm going to say a is equal to 2. And I see when I plug that in, both of these give me the same variable output, which is -9. So these two are equal. So my answer is x is equal to 2. Let's do another example now. So our first step is we want to make sure both expressions are simplified. So here it looks like all of my like terms and everything are good. So I just need to simplify the right-hand side. And I'm going to do that by distributing this -1/3 times the 2w minus 9. So let's just copy down this left-hand side. And now I can also use Desmos just to multiply this out. So I have -1/3 times 2. I don't need the w. If I make that into a fraction, we're going to have -2/3 w. And then -1/3 times -9 would get me a +3. Now let's get all of our variables and all of our constants on the same side. So again, I like to move my smaller variable first. So I'm going to move that this way, which means I need to move this constant to the other side. So I have 5/6w plus 2/3w, because I changed that sign since I'm moving it over, is equal to 3, and then minus 21. Now let's combine these like terms. So on the left here, I have 5/6 plus 2/3. And if I make that into a fraction, I'm going to get 3/2w is going to be equal to 3 minus 21 is going to get me -18. Now on that third step in our notes, we said we're going to divide or multiply to cancel out the w. So I've got 3/2. What I'm going to do is multiply by the reciprocal to get that to cancel out. And the reciprocal is just the same fraction but flipped. So instead of 3/2, I'm going to multiply by 2/3. And that will get it to cancel. And so I'll multiply the right by 2/3 as well. And when I do that, I can do that down here and say -18 times 2/3 is going to get me -12. Now let's check this in Desmos. So I'm going to clear out what I've got. We found that w is going to be equal to -12. Now let's type in our two original expressions. I had 5/6w plus 21. That's going to get me 11 when I plug -12 in for w here. And -1/3 times 2w minus 9, that also gets me 11. So I can put a box on my answer because I know it's right. Let's do one more example. Okay, so this time we have a fraction going on here. And so what we want to do whenever we have that fraction is it's easiest just to eliminate that, that fraction. So how I'm going to do that is I'm going to multiply the entire thing by 2/1, or just 2. Because when I do that, I can cancel out that 2, and it's just going to leave me with the 10x plus 17 minus x minus 9. And now I just need to distribute this 2 over here. So 2 times 3 would give me 6x, and 2 times 1 gives me 2. We've got a lot more simplifying to do on the left, though. So I've got -1 times the x minus 9. So I have 10x plus 17. And then I'm going to have -x plus 9 is equal to 6x plus 2. And now I'm going to combine my like terms, which is the 10x and the -x, and the 17 and the 9. So 10x minus 1x will give me 9x, and 17 plus 9 will give me 26. And so now both expressions are simplified. So we're going to go ahead and get all of our variables and constants on the same side. So 6 is my smaller variable, so I'm going to move that over here, which means I'm going to need to move the 26 to the right. So I have 9x plus 6x is equal to 2 minus 26. When I move, I change all the signs. And so now 9x plus 6x is going to give me, this should be a and negative x, okay? Always make sure you're checking yourself. So 9x minus 6x is going to give me a 3x. Then I have 2 minus 26 will give me negative 24. And so now I can just divide by 3. So I'm going to get x is equal to negative 8. Now let's check this in Desmos. So again, x is a graphing letter, so I'm going to change this to a, and we're going to say a is equal to negative 8, which we just found. And now my left expression was 10a plus 17 minus a minus 9. That gives me negative 46. And on the right, my original expression was, oh, whoops. Remember, this was all over 2. And then on the right, it was 3x plus 1. Oops, and we need to make sure that's an A. There you go. So a little bumpy road getting there, but we do see that both of those expressions are equal when x is equal to negative 8. So we found our solution. And this has been our lesson over solving linear equations. Good luck in your practice, and I'll see you in the next video.